Right now, electricity is flowing through the device in your hands. It's flowing through your phone, your computer, the lights above you. You've used it every single day of your life. You depend on it completely. So naturally, you understand it, right? Here's a test. When you plug your phone into the wall, what's actually happening? Where is the energy coming from? What is electricity, fundamentally? If you're hesitating, you're not alone. Most people give answers like, it's energy flowing through wires, or electrons moving from one place to another. But here's the uncomfortable truth. Those answers don't explain anything. They just give the mystery a different name. The reality of electricity is so strange, so fundamentally bizarre, that everything you think you know about it is probably wrong. Let me show you something that will change how you see the world. Get a piece of plastic. Could be a plastic bag, plastic wrap, doesn't matter. Tear off a strip. Now rub it vigorously between your hands, fast, like you're trying to create friction heat. Got it? Good. Now slowly bring it close to your arm without letting it touch. Hold it maybe a centimeter away from the tiny hairs on your arm. Do you feel that? The hairs are moving. They're standing up, bending toward the plastic. The plastic is pulling on your body from across empty space. Stop right there. Think about what just happened. You rubbed plastic with your hands, that's all. No battery, no power cord, no external energy source, just friction. And now, that piece of plastic can exert force on your body without touching it. It's reaching across the gap through what appears to be empty air and moving parts of you. In your everyday experience, forces require contact. You push a door, your hand touches the door. You lift a cup, your fingers touch the cup. Objects only affect each other when they're touching. That's intuitive. That's how the world seems to work. Except here you are, holding plastic that's pulling on you through space. Most people dismiss this. Oh, that's just static electricity, kids stuff, science class demonstration, and they move on. But you shouldn't move on, because what you're witnessing is one of the 4 fundamental forces of the universe, demonstrating its ability to act across distance. This is the same force that holds every atom in your body together. The same force that makes all of chemistry possible. The same force that allows your brain to think, your heart to beat, your eyes to read these words. So what actually happened when you rubbed that plastic? You transferred electrons. When you created that friction, you literally scraped electrons off your skin and deposited them onto the plastic surface. We're talking about maybe a few trillion extra electrons piled onto that piece of plastic. That's a tiny, tiny fraction of the total electrons in the material. Maybe 1 excess electron for every trillion atoms. Now here's where it gets wild. Those excess electrons hate each other. I don't mean that metaphorically, I mean they repel each other with a force so enormous that the human mind cannot really grasp it. Let me try to give you perspective. Take 2 electrons, place them 1 centimeter apart in empty space. The electromagnetic force between those 2 electrons, the force pushing them apart, is approximately 10 to the power of 42 times stronger than the gravitational force between them. Read that number again. 10 to the 42nd power. That's a 1 followed by 42 zeros. That's a trillion times stronger than gravity. For electrons, for charged particles, gravity is essentially irrelevant. It's a rounding error. Electromagnetic forces are everything. They dominate so completely that gravity might as well not exist at the atomic scale. So here's the question that should be bothering you. If electromagnetic forces are that incomprehensibly powerful, why isn't matter constantly tearing itself apart? The answer is balance. Perfect, exquisite, precise balance. Think about what an atom actually is. At the center, you have a nucleus containing protons, each one carrying a positive charge. Orbiting around that nucleus, you have electrons, each carrying a negative charge. And here's the crucial thing. Positive charges repel positive charges. Negative charges repel negative charges. but positive and negative attract each other with exactly the same magnitude of force. In normal matter, you have an intimate mixture of positive and negative charges, packed as close together as quantum mechanics allows. Every proton is surrounded by electrons. Every electron is surrounded by protons. The enormous repulsive forces between like charges are perfectly cancelled by equally enormous attractive forces between opposite charges. Net charge, 0. Net force, 0. Everything is balanced. But the forces are still there. Those monstrous electromagnetic forces are still acting, still present, still powerful. They're just balanced so perfectly that the net effect is 0. And because the underlying forces are so huge, even the tiniest imbalance creates effects you can see and feel. When you rubbed that plastic, you moved maybe 1 electron in every trillion. That's essentially nothing, a microscopic fraction of the total charge. But it's enough to make your hair stand up, because when the baseline forces are that enormous, even the smallest excess creates a noticeable effect. This completely changes what it means to touch something. Pick up an object, any object, a mug, a book, your phone. Hold it in your hand. What are you feeling? You think you're feeling solid matter, right? Physical substance, the stuff of reality. Wrong. You're feeling electromagnetic repulsion. The electrons in your hand are pushing away from the electrons in the object with tremendous force. The reason you can't push your hand through the object isn't because matter is solid in some inherent way. It's because the electromagnetic forces are so strong that the electron clouds refuse to overlap. Your hand is not touching the object. Not really. Not ever. There's always a gap, incredibly tiny, measured in fractions of a nanometer, between the atoms in your hand and the atoms in the object. You're feeling force acting across distance. You're feeling the electromagnetic force pushing back against you. And here's the thing that should restructure your entire understanding of reality. Every force you have ever felt in your entire life is electromagnetic. Every push, every pull, every sensation of pressure, resistance, texture, all of it is electromagnetic forces acting between electrons. You have never touched anything. When you think you're making contact, you're feeling electrons pushing against electrons through empty space. The same phenomenon you saw with the plastic wrap, just acting at much smaller distances, where the forces become incredibly intense. Now let's talk about how electricity actually works in wires, because everything you've been told about this is misleading. You have a copper wire running through your wall. One end connects to the power source. The other end connects to a lamp. You flip the switch. The lamp turns on instantly, or at least, it seems instant. The standard explanation: electricity flows like water. Electrons enter the wire at one end, flow down its length like water through a pipe, and emerge at the other end to power your lamp. This explanation is fundamentally wrong. Electrons in a wire move incredibly slowly, about 1 millimeter per second. That's slower than a snail crawls. At that speed, if you turned on a switch, it would take an electron nearly half an hour to travel across a typical room. But the light comes on immediately. So what's really happening? Here's the key insight. The wire is already full of electrons. Copper is a metal, and metals have free electrons. Electrons that aren't tightly bound to individual atoms, that can move around freely throughout the material. The wire is like a pipe that's already completely full of water. When you close the switch, you create a voltage difference, an electric field along the wire. That field pushes on the electrons at one end, but because electrons repel each other across distance, that push is immediately transmitted to the next electron, which pushes the next one, which pushes the next one. It's like a line of people standing shoulder to shoulder in a hallway. If you push the person at one end, the person at the other end feels it almost immediately. Not because the first person walked down the hall, but because the push was transmitted through the crowd, person to person, almost instantly. The signal, the push, travels through the wire at close to the speed of light, not because individual electrons are moving fast, but because the electromagnetic force acts across distance. And that force can propagate changes very quickly. But where does that push come from? Let's trace the electricity back to its source. Your lamp connects to an outlet. The outlet connects to wiring in your walls. That wiring connects to power lines outside. Those power lines connect to a power plant. Maybe it's 10 miles away, maybe 100 miles away. And at that power plant, something is spinning. A massive turbine, weighing many tons, rotating at thousands of revolutions per minute. And that mechanical motion, happening miles away from your house, is what powers your lamp. How is that possible? How can spinning metal in one location cause light to appear in a completely different location? The connection is magnetism. And here's the crucial fact that most people don't realize. Electricity and magnetism are not two separate things. They're two aspects of the same fundamental force, the electromagnetic force. Moving electric charges create magnetic fields. Changing magnetic fields create electric currents. They're inseparable, two sides of the same coin. Here's how a generator works. You spin coils of copper wire inside a magnetic field. The magnetic field exerts force on the free electrons in the copper. As the wire moves through the field, the electrons experience a push. They're forced to flow. That flow is electric current. Motion plus magnetic field plus conductor equals electricity. Now run it backward. Push electric current through copper wire that's inside a magnetic field. The magnetic field exerts force on the moving electrons. The force acts on the wire itself, causing it to move. That's an electric motor. Same physics, reversed. Generators convert mechanical motion into electrical current. Motors convert electrical current into mechanical motion. And the reason any of this works is because electricity and magnetism are unified. They're different manifestations of the same underlying electromagnetic force. Think about how extraordinary this is. You spin magnets near copper on one side of a city. Copper moves. That motion creates a push that propagates through thin metal wires at nearly the speed of light across miles of distance. The push reaches your house, causes electrons to flow through a filament. The filament resists, heats up, glows. Light. Water falling over a dam makes turbines spin. Copper moves through magnetic fields. Electrons get pushed. The push travels through 100 miles of wire. Your refrigerator motor turns on. Water falling in one place makes metal spin in another place, connected by nothing but thin copper wire carrying an electromagnetic signal. You don't even need permanent magnets for this to work. Take a coil of wire, run current through it. The moving electrons create a magnetic field around the coil. Now place a second coil of wire nearby. Not touching, just nearby. As the current in the first coil changes, the magnetic field changes. That changing magnetic field reaches across the gap and pushes on the electrons in the second coil. Current flows in the second coil even though there's no physical connection between them. That's a transformer. And transformers are everywhere in the power grid. They're how we step voltage up and down, how we transmit power efficiently over long distances. It's just copper, just coils, just changing electromagnetic fields, coupling across empty space. Metal talking to metal through invisible fields. The power grid is a vast network of generators, transformers, and motors, all using electromagnetic induction to move energy across enormous distances. And it all works because of this one principle. Moving charges create magnetic fields. And changing magnetic fields move charges. Now, here's where we need to go deeper. I said earlier that every force you feel is electromagnetic. Every push, every pull, every sensation of resistance or pressure. But think about what that actually means. The forces we call mechanical forces, the everyday forces of touching, pushing, lifting, pressing, those aren't fundamental. They're derived. They're consequences of the electromagnetic force acting at the atomic level. When you push on a door, you're creating electromagnetic repulsion between the electron clouds in your hand and the electron clouds in the door. When you stand on the floor, you're held up by electromagnetic repulsion between electrons in your feet and electrons in the floor. When light enters your eye, you're detecting oscillating electromagnetic fields, causing electrons in your retina to move, triggering chemical reactions that send signals to your brain. Chemistry? That's electromagnetic forces between electrons in different atoms. Heat? That's atoms vibrating, held in place by electromagnetic forces. Sound? Pressure waves transmitted through electromagnetic forces between molecules. Biology? That's chemistry, which is electromagnetic forces. Your entire sensory experience of physical reality is electromagnetic interactions. Everything you see, touch, hear, taste, smell, it's all electromagnetic forces acting on the charged particles in your sensory organs. And here's the deepest thing. You cannot explain the electromagnetic force in terms of anything simpler. You can't say, it's like a spring, or it's like a rope, because springs and ropes are made of electromagnetic forces. The electromagnetic force is fundamental. It's one of the 4 basic forces of nature. It's a brute fact about reality. You have to accept it and then explain everything else in terms of it. This is uncomfortable because the electromagnetic force acts at a distance, and that violates our evolved intuitions. We evolved to understand contact forces. Push rock, rock moves. Our brains are wired for a world of direct mechanical interaction. But that world is an illusion. Contact doesn't exist. There's only electromagnetic forces acting across extremely tiny distances. To truly understand electricity, to really understand it, you have to rebuild your intuition from the ground up. You have to accept that the universe is made of fields that permeate all of space. That charged particles push and pull on each other across those fields. That action at a distance isn't some weird exception. It's the fundamental rule. When you flip a light switch, here's what's really happening. You close a circuit. Electrons throughout the entire circuit start moving, slowly, about a millimeter per second. But they start moving everywhere almost simultaneously because the electromagnetic signal propagates quickly. At the power plant, a turbine spins. Magnets rotate past copper coils. The changing magnetic field pushes electrons. Those electrons push the next electrons. The electromagnetic signal propagates at nearly light speed through hundreds of miles of wire. The signal reaches your bulb. Electrons flow through a thin tungsten filament. The filament resists their motion. Resistance generates heat. The filament gets hot enough to glow white hot. Electromagnetic waves radiate outward. Some of those waves hit your retina. Oscillating electromagnetic fields cause electrons in your retinal cells to move. Chemical reactions cascade. Signals propagate through your neurons. Your brain processes the information. You perceive light. Every single step is electromagnetic. The turbine spinning. Electromagnetic forces holding the metal together. The signal propagating. Electromagnetic repulsion between electrons. The resistance. Electromagnetic forces making it hard for electrons to move through the filament. The light. Electromagnetic waves. Your vision. Electromagnetic forces triggering chemistry in your eyes. Think about the historical scale of what happened. 200 years ago, none of this existed. Electricity was a laboratory curiosity. Then we discovered these forces, these principles. We figured out how to manipulate them. We built machines, generators, motors, transformers. We constructed systems to generate electricity, transmit it across vast distances, and use it to do work. And in doing so, we completely transformed human civilization. Electricity gave us instant communication. Telegraph, telephone, radio, television, the internet, all electromagnetic. It gave us artificial light, allowing cities to function 24 hours a day. It gave us electric motors, machines that could do work without relying on human or animal muscle power. It gave us computing, billions of microscopic switches manipulating electromagnetic forces to process information. every aspect of modern life runs on electricity. And it's all based on one insight. There's a fundamental force that acts across distance. And if you learn to manipulate it, you can do things that would seem like magic to anyone living 2 centuries ago. So what is electricity really? Electricity isn't a thing. It's not a substance, not a fluid flowing through pipes. Electricity is what we call it when we manipulate the electromagnetic force to transmit energy and do useful work. But more fundamentally, electricity is proof that the world is not what it seems. The world appears mechanical, solid objects pushing against each other through direct contact, like billiard balls on a table. But that's an illusion built by our limited senses and our evolutionary history. The real world is made of fields and forces acting at a distance. It's particles pushing and pulling on each other through empty space. It's electromagnetic fields permeating every cubic centimeter of the universe, coupling charges together across vast distances. When you see plastic attract paper, you're seeing the fundamental force that makes chemistry possible. When you turn on a light, you're commanding electromagnetic fields that extend throughout all of space. When you understand this deeply, everything changes. You realize the world is electric, that forces act at a distance, that solid matter is an illusion, a carefully balanced dance of attraction and repulsion. And you realize that humans figured this out. We discovered these forces through careful experiment and mathematical reasoning. We learned to manipulate them. We built an entire civilization on top of them. That represents one of the greatest triumphs of human intelligence. So the next time you flip a switch, remember, you're not just turning on a light. You're manipulating one of the fundamental forces of nature. You're making electrons push each other across entire cities. You're converting rotational motion into electromagnetic fields and back into motion. You're wielding power over reality itself. And that's what electricity really is. Not a utility, not a convenience. A window into the fundamental nature of reality, and proof that humans can understand and manipulate that reality. That's the truth about electricity. And the truth is far stranger and more wonderful than anything we're taught in school.